Hello everyone, I'm Maxim Roffe, and welcome to this talk about a 3D Brawler game using a hybrid planning approach. This game is named Kayora and has been a part of my graduation year at ISA Digital Paris. So now, let's begin. First, let's set up some definitions. So what is a 3D Brawler? It's a hand-to-hand combat game where the player fights a large number of opponents, brawling against them all, which can somehow remind of the arcade genre. And on the top of that, a highly developed combat system to bring gameplay depth. Games such as God of War or Devil May Cry can be taken as references here. So the question is, how to ensure both combat dynamicity and game design requirements? Let's start by taking a look at the first component of this hybrid, the GOAP. GOAP, for Goal-Oriented Action Planning, simply means that we have a pool of possible actions called action sets, and we will try to generate a plan that achieves a specific goal at a specific time. Each possible action of this action set has a heuristic. The higher the heuristic is, the more chances the action gets to be added to the plan. Here is an example of a simple action set for the goal patrol. It is composed of 3 actions: idle, the AI just waits, choose target to set a new target, and a move to move toward the target. First, we need to choose ending actions that will achieve the goal. Once they are successfully added to the plan, the algorithm ends. Also, some actions may have additional requirements, known as pre- and post-conditions. Here, move to requires a target, that's why we have the choose target action. Now everything is ready for the generation, so let's take a look at all the possible output plans. The first one would simply be idle. Then the second one, choose target and move to. And the last possible one, choose target and idle. In this last case, the choose target seems useless and time-consuming since the new target is not being used, but it not exactly is. In fact, a next possible plan generated after this one could simply be move to. The second component of this hybrid is the HTN. Let's dive in. HTN stands for Hierarchical Task Network. It means that we have dependencies among actions themselves. These dependencies came down with what is called a compound task or task chain, which is an action composed of static sub-actions. This chain of sub-actions and their order is defined by designers and never changes. It is a well-defined behavior. A precise example in Kayora would be the attack chain. The AI starts by playing feedbacks to warn the player, then move towards him before attacking when at range. In order for this feature to work properly, every requirement in the child actions must be forwarded to the parent. So why did we come to this hybrid solution? Let's get into the advantages, starting with the GOAP. First, a great gameplay replayability. AIs will keep generating new plans and thus behaviors, and with a wide diversity of actions in the action sets, a wide diversity of behaviors would be generated. Then, dynamic environment adaptability. Each action has a heuristic, which can be a static number, but also dynamic parameters of the game, such as the player's health, the number of AI in the arena, or even the number of AI performing a specific action at a time. In Kayora, the aggressiveness of the AIs depend on both the player's health and the number of AI fighting. And last, iterative behavior creation. Yes, since we just need to add new actions to the action sets without rewriting anything else, the development becomes iterative in itself. Starting with a simple 3 actions patrol set in the early stages of development is enough, and then upgrading the patrol behaviors by providing new actions is straightforward. Now, on the HTN side, static well-defined behaviors can be created, and the conception and balancing of AI are facilitated. Since with the GOAP we only know what the AI can do, but not what the AI will do, the HTN component comes to fill the needs of the designers. Game design codes are guaranteed to be respected, with the example of playing feedback before the attack. And in the end, the planning is being used at runtime, so the AI budget constraints must be met. So now, let's take a closer look at the results in-game. In this first situation, the two AIs are being very aggressive and keep attacking the player. The player has great health, and there are only 2 of them in the arena. Using the planning, one chooses to stick with melee, while the other decides to step back to be able to charge the player. Thanks to the HTN component of the planner, the charging AI will always warn the player before its attack. It will turn right first, then raise its claws before charging. In the second configuration, the player has low health, so the AIs are less likely to attack. The first one gets to absorb the puddle, which is a threat to the player, while the other one simply sidesteps and observes before attacking again. Despite being non-aggressive, the AIs keep being interesting by facing the player to new situations thanks to the planning that ensure the immersion. I will now go through some usual gameplay questions. The first one is an AI aware of the others? And is there a director for group behaviors? In this design, AIs are not directly aware of the others. However, by using the dynamic gameplay parameters as I mentioned before, the GOAP algorithm will generate different behaviors. The example of the absorbing action is relevant. Its heuristic is dynamic depending on the number of AI currently already absorbing. If none of them are absorbing, the heuristic will be 2. If 2 of them are already absorbing, the heuristic will be 0, which means the maximum of AI absorbing is 2. Concerning the director, we didn't have the need for one within Kayora. Since we are battling in an arena, behaviors remain quite simple, and group behaviors are just emerging from the GOAP. Going further, the role of the director will be to dispense more precise goals. Instead of having only one goal attack, it could be split into more explicit ones with new actions specific to this one goal. Another question is about how to build strategy with planning. This screenshot is the top view of the arena. Of course, we have the absorption points in blue that are interesting for both the player and the AI, but also some additional strategy points in red. These points are places with a large view of the arena, where the ranged AI can shoot powerful lasers. Depending on the plan, some AI will choose to take one of these points, and if the player does nothing about it, the situation will quickly get out of hand. Thank you for listening. Feel free to play to Kayora on itch.io, check the planning plugin on my GitHub, and find all the useful links in the description below.